Okay, as the first stage, let's see the true velocity and actual velocity. Look at this diagram. The first one, A is running from left to right, that is west to east. He is running 2 kilometers per second. So the true velocity is represented by VA, that is 2 meter per second. Look at the second diagram. A cyclist cycling from east to west of 20 kilometers per hour. So here true velocity is represented by VC. So you can take C is for velocity, C is for the cyclist, VC stands for velocity of the cyclist, 20 kilometers per hour. Here we are saying this velocity is true velocity. True velocity or actual velocity, which is nothing but the velocity of the moving object with respect to the ground or relative to the earth speed. So the velocity of a moving object P relative to the earth is known as the true velocity, and it is denoted by Vp. If the object is P, so then you can call it as P. In the next case, let's see the two positions P and Q from west to east. Person A is jogging from P to Q of 2 meters per second. The time taken to cover P to Q is 30 minutes. What's the total distance? So the distance is nothing but the distance of PQ is the velocity of the person into the time taken. Velocity is 2 meters per second. Here you can see time taken is 30 minutes. 30 minutes you can convert in the form of seconds, which is 30 into 60 seconds. So the distance would be the velocity into the time taken. Velocity is in meters per second, so the time also we convert to seconds. So it's 2 into 30 into 60, which is 3600 meters. Also you can write 3.6 kilometers. Last case we saw true velocity, means the velocity of a moving object with respect to the ground. Now in this case we see relative or apparent velocity and its path. In this case there would be two moving objects. Let's look at the diagram. There are two persons moving, P and Q. The boy P is moving from west to east and the girl also moving from west to east. The boy is moving at the velocity of 3 meters per second and the girl is 2 meters per second. Now for the girl as observer, the boy P is moving 1 meter per second towards the girl or towards east. Right, I repeat, for if you take Q as observer, the girl can observe P is not moving at 3 meters per second. P is moving 2 meters per second because already she is moving 2 meters per second, so that the boy seems that he's moving 1 meter per second towards east. So this is called a relative velocity. So this we can represent velocity V, velocity of P as Q as observer. You can write Vp given Q, right? So this is velocity of the moving person P as Q as observer, right? So this is nothing but 1 meter per second, right? So since both are moving towards east, this is also towards what? East only. Now if P is observer, if we observe Q's movement, since P is already traveling of 3 meters per second and Q is moving 2 meters per second, P is faster than Q. So this relative velocity can be expressed. Velocity of Q as P as observer is again 1 meter per second. This you have to take negative, otherwise you write due west. 1 meter per second. 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 1 or it is towards him. So this is relative velocity. Based on their speeds, we can compare. In case if both of them are moving at the same velocity, 3 meters per second, then they are maintaining the same distance, right? So then there is the relative velocity would be 0 meter per second, where it is Vp given q or Vq given p, whatever. So the definition is the velocity of a moving object p relative to another moving object q is known as apparent velocity, and it is denoted by Vp given q, right? So if we take the other way around, it would be change in the negative sign. That's what the last point says. Now look at this question. The diagram, A and B are two fixed points on straight line path, and the distance between them is 30 meters. A boy P jogs from A at a speed of 3 meters per second due east. A girl Q jogs from B at a speed of 2 meters per second in the opposite direction. The previous case, we considered both on the same direction, and now they are in the opposite direction. Now we are going to find the velocity of P relative to Q, right? Velocity of P relative to Q has to be represented by Vp given Q, right? And you see velocity of P as Q as the observer. So what it would be, since both are in the opposite direction, so their relative velocities you have to add. There is 2 plus 3, which would be 5 meters per second, right? And the next case is, what is the time taken for P and Q to pass each other? Now consider if only P is moving, not Q moving. So then P will approach Q at 3 meters per second. On the other way, if P is not moving, only Q is moving, if you take, then Q can meet P with the velocity of 2 meters per second. But here, in this case, both are moving. P is moving at 3 meters per second and Q is moving 2 meters per second. So their total velocity means the relative velocity is 5 meters per second. Actually, the total distance given is 30 meters. You see here, the total distance is 30 meters. So the time taken would be distance upon speed. 30 divided by 5, which is 6 seconds, they can meet each other, right? So now, hence we can conclude the relative velocity equation. The relative velocity equation is Vp, velocity of P is nothing but the velocity of P given Q plus velocity of Q. This equation we are going to use frequently. Otherwise, we can write V of P given Q is nothing but Vp minus Vq.